EMF and Potential Difference version 1.
Electromotive force, or EMF, is actually the electrical energy per unit charge provided by an electrical energy source, for example cell or battery, when the charges pass through it. What are these charges? These charges are actually free electrons. The free electrons move from the lower potential of the battery towards the higher potential of the battery, and in the process, the free electrons gain electrical potential energy. The electrons do not move from higher potential to lower potential. Please take note of that. Electromotive force, or EMF, is measured in volts, not in Newton. If the EMF of the battery is 1 volt, it will mean that when 1 coulomb of charges move from the lower potential of the battery towards the higher potential of the battery, there is a gain of 1 joules of electrical potential energy. 1 joules of electrical potential energy per 1 coulomb of charges. If the EMF is 5 volts, it will mean that when 1 coulomb of charges move from the lower potential towards the higher potential of the battery, the charges gain 5 joules of electrical potential energy. 5 joules of electrical potential energy per 1 coulomb of charges. When the switch is closed, the free electrons move from the lower potential towards the higher potential of the battery, and in the process, the free electrons may move through electrical components like a light bulb, and light energy is produced. The light energy is a form of non-electrical energy.
To talk about how much non-electrical energy is produced, in this case, light energy of a light bulb, scientists coined the term potential difference. The potential difference, or voltage, is the non-electrical energy produced per unit charge as the charges pass through a component.
The non-electrical energy must have come from somewhere. In this case of the light bulb, the light energy must have come from the electrical energy of the charges which move through it. When the free electrons move through the light bulb, some of its electrical potential energy has been converted to light energy of the bulb. By the principle of conservation of energy, the loss in electrical potential energy of the free electrons must have been equal to the gain in light energy of the light bulb. The potential difference or voltage is also measured in volts like in EMF. If the potential difference between a component is 1 volt, it will mean that 1 joules of non-electrical energy is produced when 1 coulomb of charges move through it. In the case of this light bulb, when 1 coulomb of free electrons move through it, there is a production of 1 joules of light energy. If the potential difference of the light bulb is 5 volt, it will mean that when 1 coulomb of free electrons move through it, 5 joules of light energy is produced.
So far in this lesson, I have been referring to the flow of free electrons, which are the negative charges that goes from the lower potential towards the higher potential. But we can also refer to the flow of positive charges, which we consider them as conventional current. And the direction of flow is just the opposite to the direction of free electrons. Conventional current flows from higher potential to the lower potential. Please pause the video and take 2 minutes to solve this question. Pause the video and take 2 minutes to solve this question 2. The solutions to the 2 questions will be shown later. That's the end of lesson.